Welcome to all the learners, and in this lesson we'll continue with paper 1 of November 2023, questions 7 and 8. Let's get started. So question 7 asks, determine your first derivative from first principles if fx is equal to negative 4x squared. Now remember, there's always at least one question based on first principles. So first things first. So if fx is equal to negative 4x squared, it means fx plus h will be equal to negative 4x plus h squared. Please simplify before we actually start with the derivative. So it's negative 4, multiply out the brackets, and you'll get x squared plus 2xh plus h squared. Multiply in the negative 4, so it's negative 4x squared minus 8xh minus 4h squared. Now I have everything I need to do the first derivative. So let's get going. So the first derivative will be equal to the limit where h nears 0 of fx plus h minus fx. All of it over h. Remember, that formula is on the formula sheet. Now we substitute in the limit of h nearing 0 of, so for fx plus h, we'll substitute in our equation we just got, negative 4x squared minus 8xh minus 4h squared. Now subtract fx, so careful for your signs. All of it over h. We go on. So it's equal to the limit of h nearing 0. Very clearly I can see the negative 4x squared will cancel out with this positive 4x squared. So I'm left with negative 8xh minus 4h squared. All of it over h. Once again, I can't make h 0 yet. It's still in the denominator, meaning I can't divide by 0. So what can I do? Well, I can factorize. I can take out a common h, which means it's negative 8x minus 4h over h. H divides by the h. Now I am left with the limit of h nearing 0 of negative 8x minus 4h. Is there now anything preventing me from substituting h with a 0? No, it's perfectly fine. We can do it. So remember, now I don't need to stipulate the limit of h nearing 0. I can simply substitute in the 0, and the answer is negative 8x. And that is the answer for 5 marks. Make sure you practice it well to make sure you do it within 5 minutes. Let's do the next question. So for 7.2.1, first derivative, if they give me the function like this, as well as the dx. Now remember, these questions are not with first principles. We can use the short rule with the exponential laws. So for 7.2.1, I'm simply going to state that the derivative is bring the 3 to the front, 3 times 2, x3 minus 1, minus, this is to the power of 1, so it's 1 times 3, x to the 1 minus 1. 6x squared minus 3x to the power of 0, 6x squared minus 3. Remember, anything to the power of 0 equal to 1. Now we look at the next one, and clearly this first term is not in the correct format. So we'll first have to rewrite it though. So I will have that dx, start your bracket, just make sure the numbers are there, dx 7 times x to the power of 2 over 3, in over out, plus 2x to the negative 5. Now this is in the correct format. As soon as I start differentiating, taking the exponent to the front, the dx will fall away. So it would be 2 over 3 times 7x 2 over 3 minus 1 plus negative 5 times 2x negative 5 minus 1. Always take it to the front. Careful for that sign. So it's 2 over 3 times 7x to the power of negative a third minus 10 to the power of x negative 6. Now remember, your answer can't have negative exponents. So this would be 14 over 3 x to the power of a third minus 10 over x to the power of 6. Personally, I would prefer that we change all answers to surd format if possible. So remember, this is in, it's a 1, out is a 3. So it's x in over out minus 10 over x to the power of 6. And that is the answer. 7.3. For which values of x will the tangent to fx with that equation have a positive gradient? So for a positive gradient, we expect the first derivative to be positive, larger than 0. So let's quickly jot that down. So first of all, we have that fx is equal to negative 2x to the power of 3 plus 8x. So its first derivative, and if you can do the shortcut, bring it to the front, I'll get negative 6x squared plus 8. So very important, if you can simplify it without the steps in between, please do so. So I know for a positive gradient or an increasing function, this first derivative must be larger than 0. So negative 6x squared plus 8 must be larger than 0. So let's quickly give this a go. So I would just go and say negative 6x squared must be larger than negative 8. Divide by the negative 6, but remember, you need to change the inequality. So x squared must be smaller than 8 over 6. So x squared must be smaller than 4 over 3. Now, very important, it is a quadratic inequality, so I need critical values. So I would typically say x squared is equal to 4 over 3, meaning x is equal to positive 2 over square root of 3, or x is equal to negative 2 over square root of 3. I just took the square root as it's not a perfect difference of two squares. Quickly draw a little parabola, the negative 2 over 3 and the 2 over 3. And now I look, if they say it must be smaller than, it would lie underneath the line, meaning between these two values. So just remember your square roots though. So x would be between the two critical values. So x can be smaller than 2 over square root of 3 or larger than negative 2 over square root 3. And your derivative will be positive, giving a positive gradient. And that would be the final answer. Let's move on. Question 8. Given. So now I have the cubic graph. Determine the coordinates of the turning point. Now, very important, I see definitely two different formats. The one is in the typical format of ax to the power of 3 plus bx squared plus cx plus d. This one means they already factorized it and they got x minus 1 squared minus x plus 4. So please remember that. it's already factorized. But for the turning point, I need the first derivative. So I'll have to use the first format. So once again, let's first get our first derivative. So it's 8.1. Bring the 3 to the front, so it's negative 3x squared plus 12x minus 9. Remember, a constant becomes a 0. What do I know? I know at the turning points, the first derivative is equal to 0. So I'll put equal to 0, negative 3x squared plus 12x minus 9. I'll quickly divide by a negative 3 and get x squared minus 4x plus 3. So it's simply x minus 3 and x minus 1. So the turning points will be at x equal to 3 or x equal to 1. But we're not done. The question states coordinates, so I do need the corresponding y values. So if I substitute in x equal to 1 into the function, I would get a 0. So the first coordinate would simply be 1 and 0. If I substitute in the 3, I will get a value of 4. So the coordinate is 3, 4. And there we go. That's the coordinates of the turning point. Now, the next question states, draw a sketch of the graph f. Clearly label all intercepts with the axis and any turning points. So, strangely enough, they did not ask for the point of inflection. So, we'll only use the intercepts and the turning points. Let's get going then. So, first, I'll quickly make an axis more or less. Normally in exam, it will be given to you. So, x and y. So, let's first start with our x-intercepts real quick. So, I know for the x-intercept, x minus 1 must be 0. So, x will be equal to 1. With this one, x will be equal to 4. So, let's quickly have a go. So, that would be at 1 and 4. Now I go back, my turning point. I already have the coordinate 1, 0. I just need 3 and 4. Let's quickly give that a go. So it's at an x value more or less of 3 and 4. So that's 3 and 4. Now, the last step is I can also do with a y-intercept. So y-intercept would just be positive 4. But let's just clearly state that y-intercept, x is equal to 0. It means the coordinate is 0 and 4. So there we go. And remember, this one is also a turning point. So look carefully. If we look at the original equation, the a value at the front is negative. So if a is negative, we start with a decreasing function. Look at the graph. Yes, I can see we go to the 1, we turn. Go to the turning point, turn again, go through the x-intercept. So just clearly label and clearly state this is fx. And other than that, I indicated all the coordinates. Now let's move on to the rest of the questions. Use the graph to determine the values for k, for which this will have 3 real and unequal roots. Right, so if I were to bring the k over, I would literally have to say where fx minus k is equal to 0, because this is the function of fx. So I need to figure out how to move the graph up or down to get 3 unequal real roots. Right, so how will I approach this? So look carefully. As the graph is given here, I have 2 equal roots. If you look carefully, if I lower the graph just a bit, like a tad bit. Do you see I've got 3 unequal real roots? So I can keep lowering it until what happens? Until I literally reach this point. And this turning point turns on the x-axis. So as soon as this turning point reaches there, I have to stop, because now we're back at the equal roots, and they're very specific with unequal roots. So I need to lower it as quickly as possible until what? Until it goes to -4. So how will I state it? Because it can be anything larger than 0, because if I lower it with 1 unit, I will have unequal roots. So I will literally state then that k should be larger than 0, but smaller than 4. And remember, it can't be equal, because if it's equal to 4, it will have 2 equal roots at this coordinate. So very important, that's how I would determine it. The next one, the line, so 8.4, gx is equal to ax plus b, so it's a straight line, is a tangent to f at the point of inflection of f. Determine the equation of g. So definitely I need to first get the point of inflection. If I have the point of inflection, we can definitely then get the gradient and all the other necessary details. So let's quickly have a go at this. So remember, your first derivative is equal to -3x squared plus 12x minus 9. So the second derivative will be equal to -6x plus 12. So the point of inflection is where the second derivative is 0. So 0 is equal to -6x plus 12. Then I quickly solve for x, and I'll get x is equal to 2. So remember, to get the original coordinate, we need to substitute into the original equation. So f in the point or coordinate of 2, and you will get a value of 2. So the coordinate we're working with is 2, 2. That is the coordinate. Now, I need a gradient. I know the gradient of that straight line will be equal to the first derivative where x is equal to 2. So I'll sub it in to this first derivative. -3, 2 squared plus 12 times 2 minus 9. And you will get a value of 3. So I can immediately state that y is equal to 3x plus c. How do I get c? That's the y-intercept. But unfortunately, this coordinate I have is not a y-intercept, but I can use it. So I will say 2 is equal to 3 times 2 plus c, and I'll get c is equal to -4. Therefore, my equation is y is equal to 3x minus 4. And that is the answer. So let's look back. What's the last question? Calculate the value of theta, the acute angle formed between G and the x-axis in the first quadrant. So once again, if we were to look at this graph real quick, and I'm just going to erase some of these markings to clearly indicate what's going on. So your point of inflection is always between the two turning points. So if I have a straight line running through or a tangent, they are now asking specifically about this angle theta. That is the inclination angle, what we usually do in analytical geometry. So remember, don't just focus on your paper 1 when studying for paper 1. Make sure you've got the basics for paper 2 as well. Okay, so I just need the inclination angle. So if we look at our equation we calculated with y is equal to 3x minus 4, my gradient is 3. So immediately I can then state that the tan of theta is equal to 3, which means theta would be equal to the shift tan of 3. So you literally just put that in your calculator, and it's 71.57 degrees. And this is so important because it's not a negative gradient. I don't need to get a different answer. And that is all for this lesson. I'll definitely see you in the next one.